Repeating myself again for those who just came, my name is Laurynas. You can ask me questions during the talk, so feel free to interrupt. If you're unable to catch me after the talk and you have some questions, you can use the app that was mentioned here, or straight to my email, or also first visit my GitHub page where it has all the examples used in this presentation, as well as the demo application, stuff like that. So a little bit about me. I am a functional programming and DevOps enthusiast, currently doing Scala engineering and DevOps at Aggregation. I'm quite young. I have just over 5 years of professional experience. When I'm not doing coding, I'm either gaming or practicing kickboxing and visiting this. So a bit about where I work. It's called Aggregation. Our main product is called Travel Time API. It's an API that makes maps searchable by time. We sell that API to other businesses. And what that means is that, for example, one of our biggest clients is Zoopla. It's a property listing in the UK. So let's say you're looking for a new apartment to rent or buy, and you want to be able to reach that apartment in 15 minutes. Sorry, you want to be able to reach your work from that apartment in 15 minutes using public transportation. So now in Zoopla, you can filter, you can enter where your work is, and it will filter all the apartments. So you see all the relative results. There's public transportation modes, driving, cycling, other modes as well. And this picture right here shows the difference between doing a simple radius search versus our travel time search. So if you search for apartments that are within 5 miles of your work, you could still get lots of property listings that you wouldn't be able to reach within 15 minutes or half an hour. So our search provides more relevant results. And there also, as you can see, there are results that were even not returned with a simple radius search. So we're quite a small company. At the development side, we have 7 people. 2 of those people, myself included, are responsible for operations. But as I mentioned, I enjoy functional programming a lot and DevOps as well. So I don't imagine myself doing either one or the other. So our small company and flat structure allows to constantly change roles. So I'll do DevOps 1 month and then do just regular software engineering another month. We have a small amount of managed service, just under 20. The main platform, the main product that we're building is built with Scala, Akka, and Play. And we also have some single-page applications. Those are mainly built with Scala.js and the React framework from Facebook. We manage our servers and do automatic deployments with Ansible. So to begin, let's talk about the issues in most common logging mechanisms. So for this, I'll illustrate a sample application. It's extremely simple. You have load balancers, application servers, and a database. And let's talk about sticky sessions for a minute. It's not the main topic, but it's quite important for the example that I'm going to use. So let's dive into that for a minute. If you have application servers that are not stateless, you have, for example, storage information, you can use a technique called sticky session, which means that when a visitor visits your website for the first time and goes through a load balancer picks a server for him or her, and then their subsequent requests will all be routed to the same server. This is necessary so that if you, as I mentioned, if you have session information, you hit one server, you authenticate with that server. It's important that you you keep hitting that server which has your session information, so that, because if you get another server, then you have to relog in it again. Other solutions, but of course there are some downsides, like if you do a rolling deployment and turn off some servers, then the users at those servers will be routed somewhere else, and they will lose session information. So then you have to use techniques like session replication. If you don't want to use sticky sessions, then you can store sessions somewhere in a database. The Leaf framework, for example, that we use, it is completely stateless, but it supports sessions. What it does, it stores all the session information on the client side in a cookie, but of course encrypted. So you don't need any configuration, and you can scale. Single page applications usually authenticate on every request, so that's they use stateless servers. So for the sake of the example, let's say that in this example, the application servers the load balancers are configured not to use sticky sessions, so we routed to a different request each time. So we've set up logging. Let's say we have a simple web shop, and we want to capture when user searches for an item, we want to capture when a user views an item, when he adds an item to the cart, removes from cart, and then performs a checkout and pays for the product. So here's how it usually looks like. You have those servers, each of them logging information into webshop.log file or somewhere else. Now a user comes into the website, he's viewing an item, and as I mentioned, sticky sessions are off. He's hitting the first server, he's viewing an item. So now that server log file has an entry in its log that user viewed this particular item. Then he decided to add this item to a cart. What happened is he hit another server, and now another server has that information. He finally wants to do a checkout. It's yet another server, but then an issue happens. Let's say an exception is thrown at us at the stage, and the user is unable to do a checkout. Something bad happened. Now you are informed. You get a stack trace. You're informed by email or some other mechanism, and you want to find out what exactly happened here. User is unable to purchase your products. You're losing money. What you have to do in this case? You try everything you can to reproduce the bug. You need to replace the exact same step the user has taken in order to reproduce it. So now you have a bunch of servers with a bunch of log files. You have to download the log files from each of the servers. You need to filter out from each of the log files that user actions. And then you have to sort them out chronologically, and then you can replace the steps. So the issue is clear. Now let's talk about the technology stack we'll be using here to solve this issue. As you understand, the main issue is that we have logs scattered everywhere, and we need a central place to save them. For that, we're going to use Elasticsearch. It's a NoSQL database with full text search capabilities. So at that first example, if all of your logs were at Logstash, you could query it by that user ID and just get in one place everything that user has done. And Elasticsearch is also used everywhere. I mean, in production, not just for logs, but for example, in web shops as well, where you have to provide smart auto-completion or relevant search results, or just very complex posting mechanisms. So we'll be storing our log files in Elasticsearch. How are we going to get there? For that, we're going to use software that's called Logstash. Anyone using Logstash currently? Okay, a handful of people. So it's a data collection engine. It has inputs, filters, and outputs. So you tell Logstash where to take the logs from. You tell Logstash how to extract valuable information from it, and then where to put that information. So in our case, do Elasticsearch. It can also do some alerting. So for example, if an exception message is received by Logstash, it can inform you straight away to, for example, HipChat or Slack or whatever you're using for team communication. And it has lots of plugins, so your use case will probably be covered. Next is Kibana. I didn't mention this before. I said we're just going to store logs in Elasticsearch. What we're going to do as well is we'll be able to capture some very good metrics and provide and get real business value for many other use cases, not just having logs in one place. In Elasticsearch, as I mentioned, it supports various analytic tools, searches, and Kibana uses Elasticsearch to visualize those analytic searches. And you can create dashboards that are dynamic, and you can interact with the data. And I'll show exactly what I mean by it a bit later. So this is how your application stack would look with this kind of logging enabled. So until recently, you had to have software called Beaver, and also have another intermediate database, Redis. Basically, as I mentioned, Logstash can take inputs, it filters out some data, it can extract variable information, and it puts certain output. The problem is that for Logstash to be able to read data files directly, it has to be running at the same machine that the log files are outputted. So you would have to run Logstash in each application server along with your application. And it's a JVM application. It's not very lightweight, so I don't really want to do that. So to combat this, we ship logs. So we use log shipping application called Beaver, and we ship all those logs into a stack into Redis, and then Logstash, uses POP, reads from Redis, processes the data, and indexes it into Elasticsearch. Kibana isn't shown there, but then Kibana obviously reads the data from Elasticsearch. And until recently, what you're able to do now, Elastic has released a tool called FileView, which can ship the logs directly into Logstash. So there is no need for Redis anymore. The last slide I showed how people would do it until recently, and that's how we still have it. We haven't migrated yet. Now, the next slide is how we at Agilize have it. As you can see, we still have Redis, we still have Beaver, and we don't have Logstash, we have Log Processor, and at the end we have also Log Monitor. The reason behind this is we used Logstash at first, but at that point it had some issues and it kept on hanging up. So we replaced it with our in-house small application. It just does a very, very small portion of what Logstash is capable of. But at that point it worked for us, and we haven't converted it. If in the future we will need any advanced features of Logstash, we'll probably go back and try it again. During my testing for this talk and my demo application, I didn't encounter any problems in Logstash, so I suggest to try it first, of course. And then we have Log Monitor. As I mentioned, Logstash can do basic monitoring, but for our case, we monitor some different stuff. At the end of each request, we capture certain information. We capture what API client has made the call, how long did the call took, also what transportation mode was used for that search, and for our API, what coordinates was the search took place, and what response codes responsibility to return whether it was a 200 or something else. And then we have a log monitor that queries Elasticsearch, let's say every 5 minutes. Sorry, 30 seconds. It checks for the statistics for the past 5 minutes. So we see that certainly we're starting returning a lot of non-200 codes. There's probably a problem. So we're alerted in hit chat and we can jump on that problem right away. Also, if there was a certain spike in load, we have started receiving much more than usual. We can take a look at that as well. So basically, we have metrics and their thresholds, and once it goes over a certain threshold, we're alerted by that. So you can adapt those to your use case. I'm not familiar with the tool that can do this. It's just a simple application that we've coded ourselves. Now I've developed a demo API for the demonstration. So it's a single endpoint. Demo application is a single endpoint. It accepts inputs similar to what our travel time platform does. It accepts a client at travel time. Basically, travel time means that I'm standing right here. How far can I get in 15 minutes? So travel time is 15 minutes in this case. What transportation was used? Cycling, walking, driving, public transport. And then we simply log out what we got for the symbols, along with some other stuff like response time, status code, or request body, and request path. And then it's very helpful if you can log out into 2 separate files. You have one file for your general logging, debug logs, like something happened, the regular stuff that you put in your log files. And then for metrics, you have another log file, for example, metrics.log, where you just, at the end of the request, you gather all the information about it with all the metrics, and it's basically you output a whole JSON map with key value. Why JSON? Because if you output everything in JSON, your metrics, it's easy for Logstash to just process it and insert it as separate fields into Elasticsearch. Now, as I mentioned, you have to, at the end of the request, gather all the information and output it as a single file, as a single line in the log file, which is not always possible, especially if you have a bunch of microservices. Your request starts here, and then it goes to different microservices, and you want to log different stuff, different metrics along the way. So in that case, at the start of the request, you can generate some kind of a unique request ID, and then you keep logging into separate files, metrics with that request ID, and Logstash can aggregate everything with that specific request ID into a single message. And I've shown that in this demo as well. As I mentioned, we do most of our stack, most of our applications in Scala. So this is just a simple controller. Basically, as I mentioned, it accepts client, transportation mode, and travel time. As you can see, I simply call metric key and metrics logger log metrics, and I just simply log them out. It's nothing, no logic in there. And at the end of the request, just to showcase that there sometimes can be errors. If, for example, someone has misspelled transportation mode and has double G in it, we return 400. I'll show how that plays later. And this is our code that actually wraps that controller. So in the controller itself, we have, as I mentioned, those 3 parameters. But before the controller and after the controller, some other stuff can happen. So we don't know how much in total the request has taken time and some other stuff. So in this wrapper, before calling the controller, as I mentioned, we create request ID, which is just a random user ID. Then we pass that to the controller, and at the end of the request, when everything is completed, we log some additional stuff to that request ID, like response type, status code, the full request body, and the request path. Then we also pass the final message through. This is necessary, as I mentioned, for log aggregation. If you're logging with the same request ID at multiple places, the last one has to output something to indicate that, don't expect any more logs. This is the final one. So this is the file beat config. This is basically how we're going to ship the logs. As you can see, we have two log files here. So it's metrics.log and application.log. And the important part here is the document type. So for our general logs, we have myapp trace, and for metrics, we have myapp metrics. And this is important because you can have different applications sending logs into a single log stash. And then in the log stash, you can use if statements to support different logic for different applications. So if it's a simple trace log, just don't want to do anything, just stash it into Elasticsearch. If metrics, you want to extract some different values, as I mentioned, you want to do log aggregation, that stuff, and you want to put it into a separate index. Which brings me to the log stash config. The input part is simple. We simply say that we're listening for file beats events. And then this mutates and gsub says that we just, from the metrics file, we want to strip the first part of the log line, which is the time the log was received. You can, the way why I'm doing this is because the log stash can capture itself when the log event was received. And if you need a timestamp, it's usually better to just output into the metrics or the request start timestamp. Also, a bit up, you can see that I have an if statement that says if time myapp metrics. This means that I want to do this logic only if it came from that certain log file. And then don't need to pay too much attention at the bottom part. It just does log aggregation based on the request ID that I mentioned. You can again go to GitHub and investigate it a bit further. And now the outputs. Now we have everything parsed. Where do we output it? Well, if it's a trace log, we just want to put it into a log stash trace index. If it's metrics and it's the final message, because we don't want to index any intermediate messages, we put it into a separate index. And we also do the standard output because it is easier to debug. And the standard log stash is quite easy to debug. In the standard output, you see all the values that is captured. You can check if all your metrics were parsed successfully. And then when you see that it was, you can output it into Elasticsearch. And now for Elasticsearch configuration. This part is completely optional, but what I suggest to do is create index mappings for your metrics. Basically, as I mentioned, we capture a couple of stuff like request body, transportation mode, and client, but additionally some other stuff. This is just a subset of that. And as you can see, we're defining that though that field is not analyzed. What this means is that when you do all of the analytic stuff to Kibana, for example, I want to see how many requests each minute each client is making. If the client field is analyzed in Elasticsearch, then it's going to tokenize it. If your client name is consisting of two or more words or has a dash in it, it will split it into separate clients. So we want to only match exact words. So we put that the string is not analyzed. For request body, I put it not analyzed, but probably you can leave it analyzed because you may want to search for some stuff that's deep inside the request body. This is the Kibana dashboard. We're going to zoom in just a moment. Just a wide view of what you can have in Kibana after your setup. So zooming in, we have a couple of metrics. The first one at the top is requests per minute. So we can have how many requests are being made, was made in the last minute. We can also see a request per minute chart. And this is very useful. For example, once we have that running for a month or so, and we want to schedule some downtime, we can see what's the best time when the clients are using our API the least. It's not always best to do it at night. You can have customers from all over the world, so it helps. Also, all of these requests were generated by another application, random request generator app that I wrote. So to do random requests to the demo application I made, and all of that is also available on GitHub. So there's a README on how you can set up everything after you get it going. You can run that request generator, and you will have a bunch of data you can play with and play with the dashboards. Next, we have average response time. At the demo application, I didn't capture just the response time. Also added a random number between 0 and 99 because every response was completed in 1 millisecond. So I needed some variance. So you can see the average response time and the average response time chart. So you can see also, again, when your application is most busy, that way you can, if you have auto scaling with Amazon or other cloud provider, you can plan accordingly at what time of the day it's best to ramp up more servers and when it's best to take them down. The more cool features for it is that you can split in Kibana, you can split tables, split charts, and do all kinds of stuff. You really have to try it yourself. It's just too much to show. But basically, in this example, what we have is we have requests per minute per client. This is, of course, randomly generated requests. So as you can see at the top chart, most of our clients make the same amount of requests. But in a real-world scenario, you can easily see who are your biggest clients for API or something else, who rarely uses your API. And you can also monitor if you're a business and you see that someone started using way too many requests. You can, call them, say, hey, maybe you should pay up more, And for clients, you have a pie chart, which clients use your application as well. Then you have your, of course, transportation modes. Instead of transportation modes for your use case, you could have what feature has the client used. So you think, wow, we've come up with a new great feature, we should totally do it. You do it, you deploy it, and then you notice after half a year that no one's using it. And but it takes a lot of effort to maintain that code. So maybe it's a good idea to just drop that feature. Excuse me. Also, you can see here we see average response time per client. So different clients make different requests, and our API, a single request can take as little as 100 milliseconds or as much as a second. So we can see what kind of clients are making what kind of requests. If we see that one client's requests are particularly high, we can analyze what kind of requests they made, and we can see maybe if there's something that we can optimize, and how can we improve performance. Another important bit here is at the bottom right, we can see their status codes, so we can see what kind of stuff we're returning. We see that we have a lot of 200 responses and a couple of 400 responses. And as I mentioned, the dashboard is completely dynamic and you can interact with the data. And what I mean by this is also you can, at the bottom of the dashboard, if you want, you can also see some raw information for debug purposes or other fields that you don't use the visualization for. What I mean by completely interactable data is that at the dashboard, if you clicked on any client name or any value, for example, Here we clicked on a client that's 10 fans. The client names were randomly generated. If you click on that, the whole dashboard adjusts so all of that data you see is for that client. So if you click on a particular client, you can see what features that client uses, what transportation modes he uses, everything about that client. As you mentioned, as you remember, I showed where we had a couple of 400 responses. Now, what happens if we click on that number 400? The whole dashboard adjusts so we see only the requests, all of the requests that resulted in a 400 response. So in this case, we can see that all 400 responses happened when the client was head plus and when the transportation mode was cycling with double G. So when this stuff happens, we can see that probably our client has made a typo in their code. Cycling mode is not that often used, maybe on their end as well. So they probably didn't even test it and notice it. So if we see that someone is making invalid requests, at some point we can just call them and say, guys, you have an issue with your code. And that has happened a couple of times. So this is the real value. You can, as I mentioned, you can do feature measuring. Like when a feature is no longer used, you can easily remove it. And as was mentioned in our keynote at the first at room 1, DevOps has to work not only from bottom up but to top bottom, and it's hard for business people to see value in this. But there is great business value in this logging. It can show what clients use, what clients need, what clients don't need. It can show potential performance problems, and in case of emergencies, we can always have a single place with all the log files, and we can find information easily. Questions? Yes.
And also, our opinion on how long the form provide that information
Yeah, so in our company, we currently just log a single application, so we don't split by application. But you should do that. And also, we split by dates. So for the trace logs, we index in each day. There's a separate index, and the index is created automatically, so we don't have to create them manually. And for metrics, each month is we create a new index for each month. And Kibana, it's smart enough to be able to, if you select a longer range that you want to see data for not the past hour, let's say past 2 months, it can join those indexes for you. So it's just purely for performance. And how long do logs stay relevant? For trace logs, at least for us, we delete them every older indexes than 7 days. I mean, those trace logs, if you haven't had an issue like an emergency, you probably won't need them. So we just delete them after 7 days. And for metrics, we keep them, I think for half a year of data, but you can keep them as long as you want.
Sorry, I don't give you the microphone.
So, regarding the workflow version servers, what is now not using the centralized slot and regarding all of the centralized slot servers, what actually using those agents?
Like putting Logstash on each server instead of using a centralized?
Yes, Logstash, Beaver.
Yeah, so Beaver, well, if you put Logstash in each server,
it creates a mode.
Yeah, so that's the only.
If you do the centralized mode,
Yeah. Also, didn't mention this, but you can also very easily incorporate additional data into Kibana. You can have server metrics like CPU load, RAM usage, some other stuff, which is very easy to do. Just set up a job on the servers to log that information to a separate file somewhere, and then Logstash to grab it. And you can have also not just business metrics, but performance metrics and server metrics. Yes? Yeah. So when we started doing this, there was no file feeds that could send directly to Logstash, and then we kind of removed Logstash, and we have our own system now. So we kind of use file feed to talk directly to our own system, and respect to that. Yeah, I wouldn't suggest that, but it was necessary for us. But as I mentioned, if you will ever need some more advanced features, we'll probably go back and see if the issue was resolved. We had a lot of stuff. We still have all the configuration, all that kind of stuff. So yeah.
Okay, like many questions. But do you have time?
I don't need it.
Do you want to shout?
Sorry?
You have some other things in the actual number of
Yeah, as I mentioned at the end of the, we dropped Logstash, we have our own little stuff, and then at the end, we have Log Monitor that reads from Elasticsearch. So that Log Monitor, as I mentioned, it queries Elasticsearch and it analyzes the data for past some minutes. And if, for example, we have one of our most basic checks, if we haven't received any requests for a couple of minutes, that's probably something that happened. We're getting requests all the time. So we have that additional application code that reads from Elasticsearch. Also, a couple very important things. That mechanism giver or file read that ships logs to Logstash, you gotta monitor that stuff as well. I mean, it can go down and then you won't be receiving logs. So again, that at the end, our log monitor, it checks when was the last time we received a log event from each of the hosts. And if we haven't received even a trace log from a host in some time, probably either is down or file read is down. And we had that a couple of times as well. So you need to make sure that you monitor the log transfer layer.
Okay, well,
yeah, you can start answering my question. Have you developed some forms or bundles as well in some applications?
Yeah. So log aggregation is not very simple. Again, as I mentioned, if you have lots of microservices and you want to log something with the same request again, you want to aggregate the logs. The last log entry must give a flag that it's the last one. But in network, you cannot prognose that stuff. This log can be received, way later than the flag that indicates that this was the last one received. So you need to combat this. The most easiest solution is, of course, at the last layer, do a timeout, log this after a minute. It's the easiest solution. Another issue is, of course, multi-line strings. So in case of Java exceptions, exception stack trace is multi-line. It will start shipping the logs line by line, which is not what you want. So usually you want to divide logs by type. Simple trace logs to one file, metrics to another file, exceptions to the other file. Because for the exceptions file, you can define that these are multi-line logs, how it starts, how it ends, so you can ship as a single unit. So that's an issue. Also, network, again, in in my configuration, I told FileBeat to ship logs, check for new logs every 5 seconds. The default is 10 seconds. I tried to do a 0, but CPU started burning. So you want to set a reasonable amount.
And the last so I send out FileBeat using the GCP port the logs. And if you can already do transaction, you can just overload sockets on logs and so on. So I really lost some part of logs. But in PDB and before exactly such kind of logs.
In this case, you can load balance Logstash. You can have multiple Logstash installations, and you can balance between them. That works. But I don't have an example, but I've seen many schemes. And once you go in the Logstash implementation, there are many load strategies that you can use. Most common is to again, using an intermediary server. So instead of shipping directly to Logstash, you do a Redis or messaging queue, some kind which can handle, it's a plugin that can handle tons of loads, so you won't have that problem. And the Logstash reads from that message queue as fast as it can. Yeah, there's, I think, Elastic Shield, it's called. No, I don't think so, not anymore. You can, yeah, most of this you can use, I think. For the easiest way, of course, if you don't want to use something like that, you can just proxy behind Nginx and have basic HTTP authentication or something like that. You can also, Logstash can also accept public-private shares, so accept logs from only FileBeat that has that private.
Okay, one more question from comments. Windows. Maybe he asked it from outside. He asked, do you use some convention in your company? How and which data should be logged?
Usually it comes from the management. They're the people that usually look at the dashboard and see, analyze the client usage and stuff like that. So if they say that it would be cool to see that and that kind of information, start it. That's it.
Okay. So thanks everybody. And present it and small present from all managers.